Hello all, welcome to VJD Academy. This is Anil Kumar, Faculty of Digital Electronics. Today I would like to teach the basic differences between synchronous counter and asynchronous counter. If you see the previous question paper of NIC, National Informatics Center, you will find a question based upon the differences between asynchronous counters and synchronous counters. Suppose if you can able to count 5 states, what is the counter can be called? The answer is mod 5 counter. Suppose if a counter is able to count 10 states, what is the name of the counter can be? The answer will be 10 state counter or mod 10 counter. We can also call as decade counter. This is the important question that already asked in even IAS 2022, one of the bit, and also the same question asked in NIC question number 38. Sir, let us try to understand the basic differences between synchronous counters and asynchronous counter. Just make a heading here. Counters, differences between synchronous and asynchronous. Synchronous and asynchronous counters. Sir, the first point of synchronous counter is basically, sir, we know that the counters are cascading of flip-flops, which means we will try to connect different number of more than one flip-flop. We can say 2, 3 or 4, something like that, to count different number of states. Maybe 8 states or 10 states or 16 states, whatever the count may be. To count this kind of states, we are using more than one flip-flop. That is the reason we are calling it as it is a design, or it is a combination of, or we can say we are connecting number of flip-flops, more than one flip-flop in a cascaded form. Sir, if you see the diagrammatic circuit of flip-flop, here this is one flip-flop, 2, 3, and then this is 4 flip-flops. Here all are flip-flops, and these flip-flops are, we are connecting just one by one. So that is the reason we are connecting all these flip-flops in a cascaded form. That is the reason we are calling it as counter is a design of cascading connection of flip-flops. So now what I am trying to tell here is, as a first point, in a synchronous counter, all flip-flops are connected to same clock, CLK, otherwise I'll write it here, clock signal. Then it is called as synchronous circuit. Let me give the circuit diagram also to understand better. Here these are the flip-flops. Let us say 4 flip-flops I would like to take. The flip-flop 1 and flip-flop 2, flip-flop 3, and then flip-flop 4. Here, sir, this is a clock signal. I will apply. And now the same clock is applying to flip-flop 4, 3, even 2, and now finally 1. Here this equation is, or we can say the first point is telling all flip-flops are connected to same clock signal. I can say that this is called clock signal. And now the asynchronous signal. Here all flip-flops are not connected to same clock, which means here this is first flip-flop, second flip-flop, and third one, we can say fourth one, F1, F2, F3, and now F4. Here we will connect here one clock to here, and also here we will connect another clock, and we will connect another clock. Here we will connect another clock. Here clock signal 1, and now here clock signal 2, clock 3, and now clock 4. Sir, this is the structure of asynchronous flip-flops. And now coming to this is first point, of course. Here the second point is it is a fastest counter, and because we are applying different clocks to different flip-flops, we will get a slower performance for asynchronous counters. Here it is a slowest flip-flop. And now third point, here the TPD, propagation time delay. Here flip-flop TPD is less than or equal to, here less than or equal to clock signal. Here clock signal, that is the equation. And coming to here propagation delay is more, because we are applying different clocks to different flip-flops. Here we may be getting more delay. So now here TPD flip-flop TPD delay is greater than T clock, applying clock. Here the fourth point, if we see for the counter circuits, sir, in synchronous counters there is no, we can say, no decoding errors present. Here fourth one, here decoding errors will present. And now the fifth point is here. Fifth point is no transition states. No transition states, which means unidentified states. Here fifth point is transition states will present. And now the basic examples of sixth point examples, we can say this is a ring counter, and example is ripple counter, and also in ripple counter we will able to find up counter, and also we will see down counter. Here up counter will count from 1 to 10. Here down counter will count from 10 to 1. This is what. And in the ring counter we will see one important counter, Johnson ring counter. Johnson ring counter we are going to see. These are the basic differences. These are the basic differences between synchronous counters and asynchronous counters. Each statements we are going to understand while we are analyzing the different types of counters. Thanks for watching. Please do subscribe.